Hi there. So today we're going to go over a GCSE physics question, specifically to try and have a look at radioactivity and half-life. That's the main reason I wanted to go over this question. So if we have a look at it, iodine-131 emits beta radiation and has a half-life of 8 hours. So I'm going to highlight that just because it is super important for our question, a half-life of 8 hours. Shortly after a nuclear incident, spinach plants were highly radioactive because they absorbed the iodine-131. A sample of spinach leaves had an activity of 2096 counts per second. I'll highlight that as well. Before correcting for background activity, background was 48 counts per second. So then it asks us, what was the activity of the spinach leaves after correcting for background activity? So background activity, I'll go over very briefly here. Background activity is the count rate that you would pick up if there is no radioactive source present. There is constantly a count rate being picked up, even if there's no radioactivity nearby. So it could be due to cosmic rays from the sun. It could be due to having a nuclear power plant near you. It could be due to rocks and soil can emit radiation as well, very small amounts. So that's our background. So we have to take that into account whenever we're doing experiments, because if we're trying to take the count rate of a certain sample, then we've got to get rid of the background before we can measure that. So it's measured at 2096 counts per second before we take away the background. So that means that the overall activity is 2096 minus 48, which if we put it into our calculator gives 2048 counts per second. So that's the activity of the spinach leaves themselves. Okay, and then the next part of this question calculates the corrected count rate of the spinach leaves after 24 hours. So a way that I go about doing this is I draw it almost like a flow chart. And I find that it's very helpful, especially at GCSE level. It becomes less helpful at A level because you have to do more specific calculations. But okay, in the beginning, we have an activity of 2048 counts per second. Then I go, okay, we had found out that our half-life, I'm going to put that here. So I write half-life like that. Our half-life was 8 hours. So after one half-life, we're going to have half of the activity. So that means we're going to have 1024 counts per second. After another half-life, we're going to have a count rate of 512 counts per second. And you can see here, so this is 8 hours. So 8 hours has passed here and 8 hours has passed here. That means 16 hours has passed in total as we go along here. And after another half-life, which is another 8 hours, that means we're going to have gone from here where it was time 0 to 24 hours later, just like it asked us in the question. And that has a count rate then of 256 counts per second. And that's what our final counts per second after 24 hours will be. So you can do it in that kind of way, doing your half-life, and sort of sometimes it might ask you how many half-lives to go past to get to a certain activity, or it gives you a time and you can go, okay, well, if a half-life goes, then 24 hours is 3 half-lives. So it goes down to 256 counts per second. So that's just a wee way you can go about doing those half-life questions at GCSE. So thank you for watching. I hope this helped, and good luck with your questions.